Hi everyone, this is Mrs. Lee. We're on activity 2.3 right now. It's titled Axis of Symmetry. Let me get my marker here. Let's do purple. And notice in your book, you're going to be on page 32. Okay. And again, in your class notebook, which you find in Canvas, there's going to be class notebook. You would go into any one of your periods right here and then just click on Friday. The one I'm marking on right now is period 5. So, and then the Friday, if you want to look at exactly the markings that I write. All right, so now, remember we started this with our do now. So if you were not in class, this would be a good time to stop and then read this section and then do all the way to number 2A, right? So feel free to pause. And if you did it and you just want to review, then continue. All right, so remember we talked about the vertex of the parabola, and that was going to be, let's see if I can find my mouse right here. Remember, I definitely did not mark that down in class. That's going to be vertex. Right, that's going to be either the maximum or the minimum, depending on how the shape of the parabola. And that's either going to be the top or at the bottom. All right, and so there's our vertex. And then we have also the axis of symmetry that we're learning today. So remember the axis, remember symmetry in like in geometry or in like elementary school when you learned it, like it was that we called it the line of symmetry, same kind of thing, but it's the axis because it's algebra. So this is our axis of symmetry right here. I refer to it as AOS. So like I was telling 5th period, right, kids, if you like to write notes and you are, you like with our IMB, and normally I do that, but this year we're trying things a little bit differently. But if you like doing that, I would take this piece of paper, a regular sheet of paper. Actually, let me try and do this. Let's see if I could just make a page right now. I'm gonna add a page. And for your guys's, you can do that as well here. I'm gonna just minimize that. Oh, actually, I'm gonna need that later on. But what I would do is if this is your notebook page, I would just draw a line like this, like on the, like so that there's like this much of a column. And then I usually put my titles here. So I would say axis of symmetry. Ooh, probably do that in parentheses because that's my abbreviation. If this is my notes, then I would actually write it out. Axis of symmetry. And pretend that, oh, you know what? Since I can, this is a computer. I'm just, okay, so now I'm going to readjust that. Sorry. And so I would write on here, like maybe I would draw a picture here, or there are going to be formulas that you're going to see later on that I would write in here. So that would be like, so for example, since a lot of you guys already took this class, was in class today. Like for example, if we were like with factored form, right? Factored form, then I would just write x is equal to, what is it? R1 plus R2 over 2. Okay, and then that would be the formula for that. And that's all relating to the axis of symmetry. If, since I'm visual, I like to draw like pictures. So then I would also include in here like a little XY with like a parabola that maybe goes like this. And then maybe with a different color, I would be like, okay, this is the thing that I'm talking about. This is the axis of symmetry. We always make it dotted because remember that the line, axis of symmetry, is not actually part of the graph. It's just like a reference point, okay? So this is gonna be so I'll be like, if this was really my notes, I would be like, okay, this is the AOS. And usually for me, my abbreviations, whatever I make the abbreviations, I just put them in parentheses like that, okay? You may have also noticed that right here, usually when I was in college, I would make a lot of abbreviations because my professors talked so fast. And so I'm like, okay, I can't write all that down. I'm not that fast of a writer. And so on the top of my paper, I would write like what the abbreviation was and say equals axis of symmetry. So every time, because sometimes I'll make abbreviations and I don't remember what they are. And then I'm like, okay, these notes are useless to me because I don't know what that means. And so I would make sure that I have that like kind of like a key for myself so that I can remember because I'm going to need a reminder. And then usually on here, and then I would do this for, oh, where's my mouse? Oh, there you And so then once I would write some other stuff too if I need it, and then I would just draw this line. Don't you like this night, huh? And then I would and then I would write down my other stuff. Like if I'm like, okay, you know, I'm gonna want to know factored form, so I'd be like factored form. All right, and then I would say, okay, factored form. Look back in your notes, not in the notes, in the book. Right? It says what the factored form is. It says a and then x minus r1 times x minus r2. Okay, and I'd be doing stuff like, okay, right here, this is root, and this is also root. And you might wonder, well, what are these sub ones, right? These are sub because they're subscripts, so it's a little bit lower than, like you're not doing stuff like this. Like this is not a thing. That's r times 1. We don't do that. Don't write like, so it's like r and then like a sub 1, okay? So the reason why we have 1 and 2 is because let's say if you have the same person in the room and their both name is like Anne, right? So you're like, oh, Anne, no, not you, Anne, the other Anne, you know, it gets confusing, right? So what do you use? You use like last names, right? Or you use like descriptions, right? And we usually like last names because we don't want to have like bad descriptions, right? So that's what these are, the 1 and 2 are. So it's just saying like Anne 1 or Anne 2, right? So this is root 1 and root 2. So you kind of know that they're not the same. It's not the same person. It's not the same root. There are 2 distinct roots. But they're both roots. So you want to keep that R there, but then we have that sub 1 and the sub 2 just to make that distinction. Okay. All right. And then remember the A, that's going to tell us the sign of A tells us whether it's going to be open up or open down, remember? So I would say like this, you know, and say if positive, so positive, or you can write like POS or write it out. It's up to you. Then I'm going to say positive. Oh, let me do that one more time. That was not great. Oops, there goes my arrow. Positive, then it's going to be like this, remember? And if it's negative, that's going to be, and then if I want to do like an example, I would put an example in here, or that's how we write notes, okay? And this helps me. So if you do it on a separate sheet of paper, you're not typing it up, although some of these, like, I don't know how you're going to do that quadratic, the parabola graphing thing. I don't know how you would do that without, you know, while you're typing it up. It's much, you will remember more if you actually physically write it out, okay? Your body will remember this action 100 times, 100%. So while you're doing this, this might be a good way, this is also a good way, not might be, it is a good way to study for the test, okay? So basically, if you're making these notes and on the test you don't use them because you're like, oh, I don't need them, that means you did a good job. You did a good job of studying and preparing for the test. But if you're like, oh my goodness, these notes, what is it going to be? That means you're not doing a good job of preparing. You need to prepare more. Okay, so that's one way to indicate, to see whether you did a good job of studying it or not. Okay, little tip there. All right, moving on. Okay, so right here, it says, what are the equation of the axis of symmetry? Right here, we drew that in orange right here, and that was x equal to 25, because we notice right here it's between 20 and 30. So that's going to be 25 because that's halfway in between. And let me just get my color here again. And then, so that's why we wrote that here. Remember, the axis of symmetry always has to have, it has to be an equation because it's not a number, it's an equation. It's x equals 25. And it's always going to be x equals something because the axis of symmetry always goes this way, okay? At least for us. You may think, well, can it go this way too? That's pre-calculus, not us. All right, so we already drew and labeled our axis of symmetry on the graph. Hey, happy days. Okay, so it says, what do you notice about the y-coordinates of the point? I want you to see right here, the y-coordinates in the green, right? From A to A prime. If you were not in class, you do not know about the Optimus joke, the transformer joke, but that's okay. All right, so, and then this is 602, and B prime is also 602. So we notice that those, the y-coordinates are always going to be the same. Why is that? Remember, this is line of symmetry, axis of symmetry. They're always going to be symmetrical, right? So if it is 25 out this way, then it's going to be 25 out that way from the axis of symmetry. If it's not, that's not the axis of symmetry. Like that's not what would be then. Something's wrong, right? So always going to be 18. 18 over and 18 to the left and 18 to the right. Okay, and so whatever the number is, it's always going to be that same distance. So when you're graphing this, and if you're noticing that your graph is not symmetrical, then you need to fix it. Okay, so on the test, if you see it and it's not symmetrical, then something's wrong. Okay, it's not like, oh, well, this parabola is just, so be as exact as you can. All right, and I will just say the only one that doesn't have an extra point is going to be where? Yeah, at the vertex, because vertex, remember, if like your finger's on the mirror, like for the reflection, it's going to literally be at that same point. If it's like this, you should run. It's not a good, I'm just kidding. All right, so yeah, so this is the only place where the point and its reflection is the exact same point. Okay. And so basically, if you know one point and the axis of symmetry, you know the other point, because you could just be like, okay, this is 18 from the axis, so that we just go 18 more on the other side. You already know that point. Okay, so this is useful to know when you're graphing. All right, a couple other things that I want you to take notice is if we look at the blue, right, and we're looking at the x coordinates, notice that that is going to be 0 and 50, 7 and 43, 10 and 40, right? What do you notice? But do you see these patterns between these two, between the pairs of numbers, right? And somebody had noticed that it was, oh, this x is giving some numbers to this x. I'm like, oh yeah, because it was 50, now it's 43, and gave 7 to B, and it gave 10 to C. I'm like, oh, never thought about it that way. I like it, but yeah, and other people said in class that this was, they all add up to 50, right? And I was like, that's really cool, right? Because if we know that, then how does that relate to the axis, right? Axis of symmetry. Well, if they all add up to 50, and we know that x equal to 25. So basically all we need to do is take the average. What do we do when we take averages of two numbers? We're basically finding the middle, right? So what we just add them up, divided by 2, right? It's literally called the average, okay? What we know is average, but we could also say the mean, okay? So we're gonna go right here. So so I already talked about those other ones above. So these are the things that, these are the formulas that you need to write down. And I kind of wrote down on this note page right, this note page right here, a little bit. So, oh, come now. Oh, shoot, I went all the way to the bottom, sorry. All this stuff, okay, no. Didn't see that yet, we're not there yet. Okay, sorry about that. So here again, we have, here's me purple pen. All right, so this is going to be the factored form. Remember, a times x minus r1 times x minus r2. And this is just a reminder saying that this is the roots, right? And then the formula for the factored form, right, that's going to be this right here, right? And in your book, I would highlight it, I would mark it, I would write in the margin, hey, this is what it is, right? If you're not one of those people who like to take notes and you'd rather just write in your book, I like to do that too. Like as I'm studying, but then when I'm going to take a test and be getting ready for a test, I like to summarize all that by taking notes, right? And I would just add these into my note. Okay, so for now, and then the general form, which also AKA standard form, right? So this is going to be the standard form. The f of x is equal to ax squared plus bx plus c, okay? And that formula is going to be x equals negative b over 2a, okay? Now remember that this b is the same thing as this b. They are the same. It represents the same thing. That's why it's the same variable. And this a represents this a. And remember, this a is also the same thing as, that's going to be the same number. Where is the other, as this a? They're the same number. So these are the same thing, just in different forms. Like I am Mrs. Lee, but I'm also a mom, and I'm also a wife. I have different forms, right? I'm still the same person, but I have different, like, everybody doesn't just all call me mom, right? So you guys call me Mrs. Lee, my kids call me mom, and my husband he doesn't call me wife, but he calls me honey. But they're all still me, right? It's not like I'm changing, right? So it's the same thing here. These are all the same equation, same function, right? But they're in different forms, right? So this is in standard form, or general form as the book likes to call it. This is in factored form. And then there's one other form that we have, though I'm not going to tell you yet because we're not doing that yet. So next week, stay tuned. Okay, and so we went back to, this is on, I just pasted them over here because I didn't want to like keep on scrolling up and down. So this is on page 24, I believe 24 and 25. It's titled Getting Started. So it's the one where it looks exactly like this. Like it has the area of dog enclosure, and it had the, remember we talked about this yesterday? So, and if you weren't here yesterday, then you're not going to know. Look at that video. All right, so here we have, if you take a look right here, this was in factored form. Notice it has a parentheses with the variable inside. And the other one has no parentheses. The standard form has no parentheses, and it has like this x squared, x, and then a number, right? So if we look at the first one, we're like, oh, okay, well, that has the x squared and the x, well, although it's s, right? So this first one is, I'm going to see if we can write on there. Okay, here we go. I'm going to go standard form. Okay, I'm going to just go SF, okay, because it's small and I can't write that small. So I'm going to write up here, just like how I would normally do it, like at the top of my page, SF is equal to standard form. Okay, this is what I did in college, like, because, you know, sometimes I have to abbreviate. And then right here, oh, put a little arrow there. So then it looks like minus SF, and we don't want to do that. So and here, this form right here, I notice it has parentheses. And even though the first one doesn't have like a number in there, remember if there's no number in there, that's actually a +0, right? And then S minus 50, so we do have like the variable and then some other number there. So that's very much like this, this factored form, right? So I'm going to go FF. And sure enough, I'm going to just go like here. It's going to write down FF means factored form. All right. So then what we're going to do here is, oh, we're going to look at this one right here. I'm a ding dong. I'm sorry. This is what we did yesterday. That's okay. We'll do it again anyways. You're like, Miss Lee, this is not even what we're supposed to be doing. It's like, we're supposed to be finding the AOS. Oh my bad. I'm not re-recording this video. It's not happening. I can't. So bear with me. You can just fast forward, okay? You have that ability, and I won't even know. My feelings won't even be hurt, so no worries. All right, so just to finish that out, this first one, standard form, SF, yay, happy days. Second one, factored form, because we got those parentheses. I knew it felt weird that, okay, factored form. So now, on to the stuff for today, which is the AOS, the Axis of Symmetry, which is this guy right here. So you just find the middle. Like some people are like, just find the middle. I'm like, okay, just find the middle, right? And you notice right here is the vertex. And somebody had said that, oh yeah, the vertex is always on the AOS. Maybe it's the other way around. Maybe the AOS is always on the vertex. I don't know, chicken or the egg, right? So that's going to be right here. And you notice right here, so between 20 and 40, that's 30. So this line right here, this gray line, that's 30. Like, let me see if I can make it work. That line right there. But the AOS looks like it's right in between. It's going to be halfway between the 20 and the 30, which means it's going to be 25. AOS is equal to 25. The other way to do it, just in case, you know, maybe this was a little bit inaccurate because these numbers are kind of huge, right? So what you can do is you can do it algebraically. So if we know that the roots are 0 and 50, right? So that we're just going to go 0 plus 50. We're going to take this equation, this formula, right? That we found, remember, up here. And we did it in the before the previous page, right? We add those up, right? Because remember, they add up to the same thing. We divide it by 2 and we get that middle number, right? So that's literally going to 0 plus 50 is going to be 50 divided by 2, which is going to be 25. Don't just box this. It's not a thing because the AOS is not just 25. It's x equals, it's a line, right? So we need an actual, like, we need to do this. Okay, we need an equation, right? There is no line without an equation. Okay, there we go. Happy days. If you wanted to see it the other way, let's say we had the equation of in standard form and we didn't have this graph. Like it wasn't that easy for us, like right? Then what do we do? So we're going to take this. So we're going to go x equals negative. I'm going to write that negative in there. Then there's that b. The b, if you look over here, is the number in front. So the coefficient of just the x. There was no x squared, it's just the x. So when you look over here and go, well, that's not this one because this one has the s squared. This one is just the s, so we're going to look at the number in front of that. So that's going to be this 100. So since this is a positive 100, this says it's the negative of whatever the b is. Well, the negative of 100 is negative 100. Okay. And there we go. And over, and then it says over 2 times a. So I'm going to go over 2 times. And well, what's my a? A is the number that's in front. It's the leading coefficient, right? We've said that before. It's the number in front of the x squared. So the number in front of this s squared is going to be -2. So times -2, right? And I'm just going to simplify that down a little bit more, and that's going to be -100 over -4, right? And 100, so negative divided by negative, positive. 100 divided by 4, 25. Okay, so x is equal to 25. Again, restating that no matter which way we do this, either graphically or with the factored form or with the, what is it called? The standard form, same answer. If you're getting different answers, then something's wrong. Something is, either it's factored wrong or the standard form was written wrong, you're doing some calculations wrong. I would check that. Okay, especially like on a test for me, what I like to do is I like to check it with another method and see if it works, if I have time. Okay, so we're gonna do the same thing with pumpkin chunkin. This one's super easy to see. It's right here at 4. And honestly, on the test, if you have a graph and you're like x equals 4, done. You don't need to show other work. There's no other work that you need to show. Okay, you can do some calculations if you just want to check, but you don't have to. Okay, if I'm asking you what is the AOS, and you'd be like, oh, x equals 4, boom, done. Now, if you just write 4 again, that's wrong because that's not a line. Okay, so it's just a value. That's not what we're talking about here. Okay, so and we also had tried this in class with the root formula, using the roots for the AOS formula. And so that was this -0.5. I don't know if you remember the points from the last time we met, but we found these points here. So 8.5 here, so that's 8.5. Because some people would be wondering, well, what if it's negative? Then does it still work? Or do I need to make it positive or whatever? No. Even if it's negative, you take that negative value, add it with the other value, right? You add them together. So this negative plus this positive, so -0.5 plus 8.5, that's going to just be 8. We're still going to divide that by 2, and we get 4. And lo and behold, that's exactly what we were wanting. Okay, so that's a good way to check. Okay, so there we go. That's our answer for AOSs. Now we're going to skip a bit. We're going to go over to number 8. So you can just flip until you get to number 8, or you can go to page, what page is this? 35. Okay. Page 35. And so here, when I'm talking about key features of a parabola, I'm talking about domain, range, x-intercepts, y-intercepts, axis of symmetry, vertex, interval of increase, interval of decrease. Those are the things that I'm looking for. The main ones I really, really, really want you to know is the x-intercepts, y-intercepts, axis of symmetry, and vertex. Okay? The other stuff is nice to know. Actually, it'll be good for you to know right now. But like, please keep in your memory of what those are. Domain and range we're always going to do with not just parabolas, but with other things. So, you know, you should kind of make sure you pay attention to that. But these are the key, these 4 are the key, like the key features. Oh, they're the key features that are going to help you graph the parabola. Okay, so now, again, this in the green box is our function, and this is the function graph. Okay. And we're going to be doing some, the domain and the range. Remember, the domain talks about the x part, like all the values that x could be. Like, what numbers can I plug into this equation? And it's okay. And you'd be like, well, any number, right? You can square any number. It doesn't matter. And same thing with this x, right? It could be, it doesn't matter what it is. If it's a million, this x, because what's a million squared? I don't know, it's a big number, but yeah, it's just a million times a million. It's still a number, right? There are going to be some instances, not in this world of parabola land, right? But there in other functions, there are some numbers that x cannot be. Okay, this x will not be able to be, right? But in this case, x's can always be anything. There's no restrictions. Okay, x could be 0. Usually, you want to check, can x be negative? You're like, yeah. Can x be 0? Yeah. Can x be positive? Yeah, so it can be all those, right? So then that's one way to check. And then if you're like, you know, oh no, it can't be, then that's when you kind of know about your domains. Okay, so now x can be all things. So x can be negative infinity to positive infinity. And so what I had introduced in class was something called, I'm going to write it up here. It's called interval notation. We'll talk more about this when we go on Tuesday. And I'll get a little bit more specific about it, but here is the intro. Okay, so remember we always start with the smallest number, so it's going to be from negative infinity to positive infinity. Okay, negative infinity to positive infinity, And we have to put that round bracket, or the parentheses, I guess, because you cannot ever equal negative infinity, right? Because if you can equal it, that's actually not negative infinity, right? By definition, you cannot have it equal to. So that's going to be there. And then for positive infinity, again, infinity, you can't equal it. So it's going to be this round brackets, okay, just like this round. All right. So that means, so these round brackets means not including. So it's not including that number because we can't actually include that number. So now another way to write that is going to be from negative infinity. Oh, negative infinity is less than x, which is less than positive infinity. Okay, this is the same way, right? You could also say x is all real numbers if you like to write things out, right? I am a shorthand kind of person, so I'm literally like, I love interval notation. It's very useful, okay? Because this is too much as extra, okay? Again, for this one right here, for the range, that's going to be all the y values here. And if you notice, can x be any positive number or y be any positive number? Well, like, well, y can't be 5, right? Because literally the graph does not go there and will never go there, right? Can y be negative 10? Well, yeah. I mean, if we were to extend this out and go down, you know, like, let's say 4, 5, 6. Okay, let's just do 8 because I don't want to go that far down. So let's say that's a, could I extend this down and it would reach it? And you'd be like, yeah, there's a point right there. Or, I mean, technically there's 2 points, right? Because remember, it's symmetrical. So there's like the other point, like right here. Look, they're there, right? So yeah, you could hypothetically go all the way down to like a negative million, negative trillion, whatever, right? I'm not going to show you that because that's just too much. But yeah, so you could go all the way down to negative infinity, but then it does have a cap right here. And that cap that I'm using is not the cap that you guys use. But it does have a cap right here at 2. Okay, so it stops at 2. All right, so that's why we're going to say, well, from negative, so for the range is from negative infinity to 2. Can it be 2? We're like, yeah, it could be 2, just can't be above 2, right? Because a 2 is literally as high as it goes. That's why we call it the max, right? So that's why we use the square bracket, because that means it's including 2. Okay, so if we did the ones with the round bracket, that would mean, oh, it's not including 2, so it can't be 2. But we already know here that it can't be 2, right? And so the other way to write this is this negative infinity is less than y, which is less than or equal to 2. And then you notice that this was x'd out, right? The reason why this was x'd out is because technically you don't need that. Because you could just have y is less than or equal to 2. Because negative infinity is included in that. Because negative infinity, yes, is less than 2, right? So you technically just need this part right here. But if you wrote this part, like you got in the habit of it, that's fine, you're not wrong. I mean, it's just more work, that's all. Okay, and then you could literally write down y is less, but you have to say y is less than or equal to 2. Okay, you can't just say y is less than 2 because that's incorrect. It could also be 2. All right, so moving on to the x-intercepts here, right? So if we have the x-intercepts, we look at the x-axis and we'd be like, oh, it crosses 2 times. And I'd be like, where? And you'd be like, oh, 0 and 2. Okay, so you could just say x-intercepts is 0 and 2. You could do that, or this is the preferred way, but you would not be wrong if you said x-intercepts was 0 and 2, is 0, 0, and 2. That's a 2, 0. Sorry, somebody was having trouble reading that. So that is 2, 0. All right. And your y-intercept, that's where it crosses the y-axis. Since this is a function, right, it should only cross 1 time on the y-axis. If you have 2 y-intercepts, you are doing something wrong. Okay, it is no longer a function. Remember, it does not pass the vertical line test. Okay, so yep, and right here, so this 0, 0 is doing double duty here. It is not only the y-intercept, it is also the x-intercept. It is both, okay? In this case, is that always going to be the case? No, it just happens to be for this case. If you said y-int equals 0, that is acceptable as well because you've defined that it is the y-intercept, right? But if you're saying y equals 0, then that would be wrong, okay? Because y equals 0 could be here, or all these places is where y equals 0. All right, and so for the y-intercept, I'm looking for a point. Okay, so safest thing, write it as a coordinate point. And then we have our axis of symmetry. We know, remember, it's right down the middle, right? And that's 1. I covered up the 1 here somewhere, sorry. So we just x equals to 1. Remember, if there's no need for calculations, why do it, right? That's fine. You can visually see it, done. Vertex, 1, 2. We just look, okay, so there's 1 across, and I go 2 up, where you're like, well, that still looks like 1. Why isn't it 1, 1? Well, if you notice, that the units that are going up are different spacings than the ones that are going up. That are going up are different than the ones going across. So the ones going up are going by twos. Every two of those little squares is 1. So, and then if we go another 2 squares, then that's going to be 2, right? So here, they're not actually taking 2 squares, they're taking 4 squares. So 4 of these units are actually equal to 1. And then this is equal to 2. Okay, so the units are not equal here, but they've stated that, so that's fine. Okay, you always need to make sure that you're labeling, you're numbering them. Okay, so that's why this is 1, 2. Okay, and so that's why we wrote the point. You always, vertex always has to be in, it's always a point. You always have to write it in this form. All right, unless, yeah, we won't go in there. Interval of increase. This thing, I think, messed up people the most. Most people, a lot of people I noticed on the homework had questions on this. So the interval of increase, when we're talking about an interval, we go like this, right? We're talking about just the x's. We don't care about how high it is. We're talking about how wide. We're just talking about the x values, right? How far can we go, right? So when is it increasing? And remember, I told you like this parabola, like it goes down forever. So if I'm going from the left, right, I can't start from the beginning because that starts at negative infinity. So I don't know where that is. So it's going to start there and it's going to keep on going up, keep on going up, keep on going up until it hits the axis of symmetry, right? And then once it reaches the axis of symmetry, it's going to start going down, right? Until it reaches forever and ever and a day over there to the right, right? So we're just looking at the x part, not how high or how low. Okay, and if we're doing that, if you look at this green highlight, well, it starts all the way at the left, negative infinity, all the way up to 1, okay? All the way up to 1. We wouldn't say 2 because 2, again, is talking about the height. We don't care about that. We're talking about the interval, okay? So it's going to be from negative infinity to 1. Remember, negative infinity, we cannot reach there, so it's that round. Can we, is it increasing at 1? Well, we can't say that because exactly at 1, like on the parabola, it's going up, and all of a sudden, as it's turning, it is neither going up nor down, and then all of a sudden it's tipping over and going down, right? So exactly at 1, there is like literally, if you were to imagine like a line going along with the point that's tangent to the point. Tangent, remember from geometry, tangent, only intersecting at 1 point. So right at 1, it's neither increasing nor decreasing. It's not doing anything. That's what we call a turning point, okay? So, or an inflection, if you want to get mathematical about it, right? But turning point is okay too. So that's literally where you're turning, where you're not either increasing nor decreasing. That's why we put in, we put in the round bracket. It cannot be 1. It could be like 0.9999999, but it can't be 1 because right at 1, it's not doing any of those. The same thing with the interval of decrease. So right after 1, right when you pass 1, right, that's when you're going to start decreasing. That's why we go boom, and then 1 to all the way to positive infinity. Remember, we're talking about the x values, not the y values. We're not talking about how low it's going. We're talking about how far to the right it's going. Okay. That part was the part that most people were confused about. If you want to like rewind and repeat that again, go for it. I won't judge you. All right. So if you guys can also do B and C and D. Okay, I'm just going to give you the answers for them just so that you can check them. But I would recommend that if you have not done them, I think 7th period, I forgot to tell you guys, sorry. If you have not done them, then please do them, you know, and just pause it and then check it. That's the best way to learn. Okay. So for domain, again, for this one, it's going to be all real numbers. So it's going to go from negative infinity to positive infinity because it could be anything to the left, anything to the right. Range, it's going to be the lowest point right here. Well, that's a little bit difficult, but we do know that our vertex, the y part right here, that talks about how low it is, right? This point right here. So I'm going to make a note of that. So that's going to be the point. So that's going to be my lowest. And then we're going to go up higher, right? So my lowest is negative 0.25. And then it's going to go all the way up, 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 up like this. So that's going to be positive infinity. Oh, did you see my mistake? Did you catch it? All right, you're like, Miss Lee, wait, I thought it can equal that. And you're like, I'm like, you're right. I should actually have square brackets for that. Was that a mistake on purpose or an accident? No one will ever know. All right. Okay, I know. So there's going to be, that's infinity, by the way. So that's going to be the lowest the y can be, and then it's only going to get bigger. All right, so for x-intercepts, that's going to be -3, 0, and -2, 0, right? Right here at -3 and -2. Okay, y-intercept, you look on this y-axis, it's right. Oh, sorry, I was in the wrong place for that. Lost. All right, here, right here at 6. Okay, there you go. Sorry, I'm looking. I didn't mean to be so close to you. All right, so right there at 6. So we're gonna be like, okay, it's gonna be 0 because the x part comes first, and then we're gonna go up 6. All right, axis of symmetry. That's gonna be right here. It's gonna be between the -2 and the -3, which is -2.5, not -1.5, because that's like over here. Okay, that would be wrong. All right, and then a vertex is gonna be -2.5 and -0.25. And some of you guys may be like, well, how'd you get the -0.25? Like, how do you know that even, right? Well, we can kind of guesstimate, because if you look here, this right here is -1. Here is, well, then half of that is -0.5, right? So that is -0.5. And then now if you notice that line, which is now a little blurry now on my screen because I've written on it so much, that is always also at the halfway point. So what's half of 0.5? Halfway between 0 and 0.5, -0.5, be -2.5, right? So that's where that would be. Okay. And then so if you're like, still, that's still not that accurate. What if it's like a little bit above or a little bit below? Like, we don't know if it's exactly that. I'm like, you're right. So what we do, and what you would normally do, is you would just remember we have this function, right? So we're going to take, we know the x, right, which was from the axis of symmetry. We know the axis of symmetry, -2.5. And you're going to plug it in because that's the x. We know the x part. We just need to know the y part. So you just plug it into the function. So remember, this function was f of x equals x squared. I'm trying to like keep it in line, times, I'm just copying this down right from over here, 5x plus 6. I am not randomly just writing numbers down. Some people think that. I'm like, no, this is not random. This is quite the opposite of that. And so right here, instead of x, remember we're putting in the -2.5. So there's my x squared, -2.5 squared, plus 5 times -2.5 plus 6, right? Now we're going to square that, remember, because exponents come first. So -2.5 times -2.5. I just think of 25 times 25, which is 625. Don't ask me. Okay, I know that because I've been doing this for years, right? And that's going to be 2 decimal places, right? So I go 1, 2 decimal places. Or you can use a calculator. I will not judge you. And 5 times -2.5 is -12.5 plus 6, right? For me, you from here, right here, you can just plug it into your calculator. Okay, that's fine. If you want to subtract this first, that's fine. I like to do my positive numbers first and then deal with my negative. So that's going to be 6.25 plus 6, which is 12.25, plus -12.5. So that's going to give me -0.25, which makes sense because it's below. I noticed that it dips below the x-axis. So it should be negative. The y should be negative. And it should not, if you're getting like -4.7 or something like that, then you're like, something's wrong, because this is like both for the -1 and -4.7 is like down here. So yeah, that's another way you can check too, just to see if you're accurate. All right, so that's how you would find this -2.5. Interval of increase, right? Remember, we're going here, we're going down first, and then we're going up, right? So let me do the down first. So interval of decrease, remember, we're looking at just the x's, right? So it's -infinity to all the way to the axis, right? Because that's where the turning point is going to be. So that's going to be -0.25, right? Remember, it does not actually get to -0.25 because right at -0.25, that's going to be at 0, right? It is not either decreasing nor is it increasing, right? And then same thing with the interval of increase. Now we are going to start at -0.25. And right after that, it's going to tip up, right? And that's going to be up until positive infinity. Not up until, like, not this kind of up, but like going to the right kind of up. Okay? All right. Less talking, Mrs. Lee. I got you. No worries. So again, same thing. All real numbers. range is going to be, I noticed at the lowest point here. And always for this one, you don't, for these features, you don't have to start in order, okay? Actually, I should probably show you what I like to do. So this is going to be, this is in between -2 and -2.5. So this looks like it's going to be from -2.25, right? Oh, did you see my mistake? Shoot, I make mistakes all the time. That one was not on purpose. All right. It can equal -2.5, -2.25. So that's why I'm putting the square brackets. Right. For me, I usually like to start out with the vertex, right? And I'd be like, that's 0.5. And that looks like, yeah, we just talked about that. So that's going to be -2.25. Okay, that's my point. All right. And then, well, my axis of symmetry then is pretty easy because it's just this X part right here. This part I like to draw it in because I'm visual. I like to visually see it. Makes me happy. So that's going to be X is equal to 0.5. And my x-intercepts right here, 2 and -1. So 2 and -1. And some of you guys may wonder now that I look at it, well, how do you know if it's a point or if it's an interval notation? Context, okay? Context. Like this one's kind of easy because, you know, you have the square bracket right here, but if it's like this, if there are like infinities in there, we're never gonna, like, if I ask you to graph negative infinity and positive infinity, like, you're like, Miss Lee, I can't do that, right? You're literally, it's not gonna work out, right? I'm like, I'll give you an A if you can graph that. Nobody's getting an A then. Okay, the y-intercept is gonna be right here at this -2, so -2. To say it backwards, I wrote it down and then I wrote the 0 first later on. All right, interval of increase. Remember, we're going down, then we're going to go up, right? So let's start with decrease then. So if I'm going to go down, that's this guy over here. That's going to be -infinity all the way to 0.5. Remember, we're looking at the y part, the x part. Sorry, not the y part. And then it's going to hit the axis of symmetry, the inflection, right? And then it's going to go from 0.5 to positive infinity. You got that right. Even if you missed one, that's fine too. You can still pat yourself on the back. All right. So here's the domain. Oh shoot, that's bad. Okay, doesn't get old, guys. Doesn't get old. So -infinity to positive infinity. And range. Oh no, I'm not going to do that first because I like to do this stuff first. Okay, my vertex. Ooh, looks a little complicated. I can't see so well. Okay, so here's my axis of symmetry. Sorry if I'm looking so close. It's a little bit blurry on mine. Not blurry, but faded away. All right, so that looks like my AOS is going to be between 1 and 2, so 1.5. And my x-intercepts look pretty easy at 1, 0, and 2, 0, right? So these guys right here. Oh, you know, I should have color coordinated these. What you can do is write them in different colors. That might be better so that they pertain to each other. And then my y-intercept is right here at 0, 2. All right, and that means my vertex, okay, I can do this. I know my x part is 1.5 because it's on the axis of symmetry. This one is exactly 1/4 of the way to -1. So that's going to be -0.25, right? Now, let's go on to the range. Well, I know the lowest number it can be. We just found it right now is -0.25. So it's going to be from -0.25 all the way to positive infinity because it goes up and up and up forever. So can it be -0.25? I'm like, yeah, it can be. Can it be infinity? Nope. Interval of increase, same as before. So, oh, that's decreasing first. So we're going to go -infinity to 1.5. Remember, we're just talking about the x values. And then from 1.5, we're going to go all the way to positive infinity. Remember, we're just talking about the x values, not the y values. All right. And that's what I want you guys to do. That was it for today. All right. And then just make sure you guys do your homework reflection, and submit those in. Okay. Because I do read them. All right. That will be helpful. Bye. See you later. Alligator.